Hello and welcome everybody to the most recent short interview for the IATiP website. So today I'm joined with Geoff Robinson from BIM. So I wonder, Geoff, could you introduce yourself and your background, please?
Hi, Georgia. Thank you for the opportunity to chat with your audience today. In terms of myself, I am a graduate of Queen's University in Belfast. Someone told me almost 2 decades ago. I've been working in BIM for over a decade now, and I've been focused on the area of aquaculture. I've moved through the remits of shellfish and finfish, and I kind of like the idea of cross-pollinating ideas between those, and I feel that working in shellfish and finfish has allowed me to avail of that opportunity. I've always focused on sustainability as a three-legged stool. So I'd have been looking at, primarily the competitiveness element of aquaculture, but I would always have put a very specific focus on the environmental sustainability portion as well. So anytime I'd be looking at a piece of work, if I'm not going to be enhancing sustainability credentials in an environmental sense in some way or another, I generally don't pursue it. And I suppose that's probably my background as a kind of environmentalist type guy before I moved into aquaculture. So that's just a little bit about me. You'll probably see as we move through things I'm describing, there are large environmental components that aren't really of relevance to the industry, but certainly I think they enhance our industry and its reputation. So yeah, sure. Next question.
Great. Okay. So could you describe the innovation that you've come to talk to us about today, please?
Yeah, sure. I'm going to start off by saying something that no one should say when they're describing their innovation, which is there is nothing magically unique about the innovation that I'm going to discuss. It is simply the use of fresh water in marine salmonid farming, something that is tried and tested, probably over the last, 5 or 6 years, possibly the last decade, specifically for gill conditions, so such as amoebic gill disease. So what we really did was, as opposed to me now discussing freshwater and freshwater treatment, which is accepted as a treatment method, probably what I'm going to do is I'm just going to run down the problems that we encountered, how we set about solving those, and the different systems that we put in place. And quite a lot of this is applicable really in an Irish context rather than a Norwegian context or a Scottish context, and that's because of the scale of salmon farming in Ireland. So I would always say to people, look, a medium-sized salmon farm in Norway is producing somewhere between 12 and 20,000 tons of salmon. That's what we do as a country. So it's, to contextualize it, that's where we're at. It really is at that level. So we're not like a large farm in Norway that has its own well boat, its own harvesting vessel. So the topics that we're dealing with are really lack of availability of equipment. And I suppose I'll delve into it a little bit deeper, as I continue on my 10-minute monologue here. Feel free to interrupt me whenever you like. So I suppose the first thing that we established was we were using fresh water. What we really never did when we secured fresh water from natural sources was analyze that water quality. So we didn't really know what the water consisted of. Had it been raining heavily? Had it flown through a bog? Had it been flowing through limestone? So because there were a lot of unknowns there, how the fish would react in that system was relatively unknown. So we would take our salmon from a sea pen, move them into the freshwater bath, and we'd put them in there and we'd monitor them. We'd monitor the oxygen. We'd make sure they were safe. But with the best will in the world, things could go wrong when that was happening because we were unaware of the water quality and we couldn't get accurate water quality results because the treatment only lasted 3 hours and the water quality can change very quickly. So to get a sample off to an accredited lab to make sure that we had what we needed, the turnaround was, a day. So we didn't have a day to play with. This was a case of treating fish, getting the job done. So I suppose myself and another aquaculture advocate in marine salmonid farming working for Clear Seas Aqua thought that it would be a good idea to trial kind of reverse osmosis or desalination units. So of course, these things are probably always looked at skeptically initially in terms of saying, why would we need to produce our own fresh water in Ireland? It does rain a lot, specifically on the west. So we appreciated that, and I suppose we kind of extolled the virtues of knowing that the water you would produce would have a known quality, and that would provide you some backup, you know, in knowing, okay, well, the last time we kept the fish in here for 3 hours, and this was the outcome. So there was a stability with that particular treatment. And I suppose just to fast forward really quickly, because I could really talk about this for an incredibly long time, to fast forward really quickly, what we established was in certain desalination plants, and not all desalination units are created equal in terms of what they give you as the end product. What we discovered was that essentially we could hold fish in there for a much extended period of time, up to 5 or 6 hours without additional water treatments. And that would mean that we were much more likely to remove sea lice. So not only could we treat our gill conditions like AGD, we could also remove sea lice, which would not have happened as quickly in a traditional freshwater bath. And even if it did, we couldn't hold the fish in that freshwater bath for as long without extensive freshwater treatment. So really having this stability in the water supply and being able to repeat methods over and over again, it really strengthened our understanding of what it takes to treat the maladies that we were trying to target, with the bonuses that we were treating things that we didn't think we could treat.
Okay.
So
And what's the effectiveness of that treatment then?
Well, look, AGD is gone. It's similar to freshwater treatments, you know, our traditional freshwater treatments. So from naturally sourced freshwater, we can reduce AGD down to non-detectable levels. And in terms of sea lice, so this is work actually that's still ongoing with us in some iteration or another. But we're removing, depending on the type of reverse osmosis unit, again, they're not all created equally. We're looking at somewhere between 80 and 95% removal of sea lice on those lengthened treatments, which are permitted by using a desalination plant. What we have established is within maybe an hour of detachment, we get about 95% mortality in all stages of sea lice, which was a good thing because, you know, it's obviously a concern that you could be removing sea lice and they could still be viable. But aren't, you know, we've done, you know, sort of trials from 10-litre bucket up to, you know, 1,000 cubic meters of water, and we've established kind of these through rigor. We've established this is the case, so it's kind of a nice setting when you know, yeah, the sea lice that are falling off within a very short period of time, they're no longer viable and they're not something that could potentially reattach to your fish again.
Excellent. Okay. And one final question related to that. So how realistic is it in terms of costs for farmers to implement the desalination system?
Yeah, that was actually the starting point for the project. It wasn't really water quality. These were all spin-off benefits. The real, and I suppose just to contextualize it again, we don't really have many well boats in Ireland. You know, we really have access to one. So if you have one well boat that can carry fresh water, and everyone needs that well boat between the months of June and September, you can appreciate that there's going to be a lack of opportunity there. Now, supply and demand says if loads of people need a wellboat, and wellboats are big pieces of kit, they're very expensive, they have large experienced crews of people that need to be well paid to do the jobs that they're doing.
Yeah.
So if you were hiring a wellboat, let's say it could cost you something like 15,000 euros a day to hire a wellboat and have that to treat your fish. Purchasing a piece of capital equipment that you will have ownership of for the remaining 5 years of its working life at maybe somewhere between 500,000 and 750,000 euros, and then using that to produce your fresh water so you no longer need a wellboat in a very short period of time, it's a commercially viable operation. It now begins paying for itself very, very quickly. And really that's, I suppose, the way to say that this is true is in 2018, BIM brought in one trial unit, and we kind of had the buy-in of the industry. We would trial this unit in Killary. All the farms were involved at some degree or another. So we had representatives from Mowi, Manning Bay, Coron Blue, Brad on BO, they were all kind of on site, looking at what was going on, providing expertise, which was really super. There was one unit, it was a higher unit, and now 2020, midway through the year, there were 5 desalination units operating in Ireland. So every farm has seen this isn't something we can do without now. And so they've all, you know, kind of voting with your feet. That's the way I would view things to be most successful. You know, as opposed to me trying to sell a good story. The story has sold itself.
Very good. Excellent. Okay, so you said that you'd like to play a video. Do you want to try and get that running now?
Yes, absolutely. Yeah, Georgia, this is a short video that I just wanted to show you. This is really the third and final, we call it the commercial iteration of a tow bag. So if we kind of discuss the scale of our industry and the lack of wellboats, you can appreciate that it's difficult to move large volumes of fresh water at sea when you don't have a wellboat. So this was something that we kind of established early on, long before desalination plants. And the way the system would have worked would have been, you would have taken one of these smaller cages with a solid tarpaulin inside, a flexible, non-permeable tarpaulin, and you'd have filled it with fresh water, and then you towed it to wherever it needed to go. And the towing speed of that system was really incredibly slow. You were maybe traveling somewhere between 0.5 and a knot. So it was really slow. You know, it would take 4 hours to get out to the site to treat with fresh water. And then you had sort of ongoing difficulties with the weather was rough, salt water could splash from the outside to the inside. So then was your salinity going to be correct the time you got to the site where you were hoping to treat your fish? I'm actually just going to pause the video there very briefly. So what we decided was we needed to come up with a solution that would enable us to move fresh water quickly and effectively. Okay, so it would mean, so we kind of looked and said, well, okay, what's our baseline? Okay, we need this thing to be able to move at 5 or 6 knots so that we can travel a couple of kilometers in an hour instead of it taking us 4 or 5 hours, because that's half a working day gone already.
Yeah.
So we kind of started off with a small, we called it the tow bag. The company we work with, Cunningham Covers, decided they would call it the Sea Croc, which I would have to accept probably has a slightly better ring to it than the tow bag, but I still call it the tow bag, so please excuse me. So we came up with kind of the first iteration, which was small, looked at the mistakes we had made, refined it, built a slightly bigger one, and this one is now 500 cubic meters. So this system can move 500 cubic meters of water. If we actually look at the video here, you can see we're filling it with fresh water right now through this black pipe. And then there is kind of an outlet here. So that's just so the bag obviously doesn't burst. So this is the scale of the operation. This is a 126 meter salmon pen. So it's 126 meters in diameter. So this thing is 45 meters long. It's about 4 or 5 meters in diameter. It's basically a big circle, and it just has buoyancy. It's got loads of towing points. It's got multiple ways to empty. So this is really the way that the Irish salmon farming industry are probably going to move fresh water in future. Because again, we don't have access to the well boats. Sorry, we actually just did some towing trials just to make sure that it was all A-okay, and you can see the way it just tows behind the vessel there.
Yeah.
So we worked with Maui on this project up in Fanad, and they definitely provided invaluable expertise in terms of, you know, using the knowledge of skippers, you know, between BIM, Maui, and Cunningham Covers. We've created something that really has value. Again, it's all about fresh water. This is kind of just an add-on. So how can we make sure we get the fresh water to the site as quickly as we can, so that we minimize staff standing around waiting for the fresh water to arrive so they can do the treatments? Because obviously we like the treatments to be over a very short time period. If you're treating cage number 1 on day 1, excuse me, you don't want to be treating cage number 8 on an 8-pen grid 2 weeks later, because anything that's in cage 8 will begin going back to cage 1 again, because these cages are adjacent to one another. You can see in the video there in the background. So it's important to treat them as one block as quickly as we can, and this is one of the methods of doing that.
So could you explain what the next steps are for this project and activity that you're doing?
Do you know what, Georgia? Can you still hear me?
Yes.
It says my internet connection is unstable.
Okay, I can still hear you though.
Okay, you can still hear me. Okay. So the next step, there's also an intermediate step in terms of freshwater, something I'd like to tell you about. So the treatment systems that we would use typically on the farms would involve having kind of non-permeable bath, we call it, suspended inside a salmon cage. So we fill it with fresh water, we pump in the fish. When we finish the treatment, we can just leave the fish out and they just swim straight back into the pen. So previously we were using cage pieces for this. So if you imagine a salmon cage, it maybe has 2 or 3 rings around the outside and it has a handrail. So we would have a spare piece that would span about 1/3 of the cage.
Mm-hmm.
So again, working with the industry, we sort of established that it probably isn't a great working practice having a 25-meter long piece of HDPE plastic floating around to tie on. So just based on, I suppose, rigid hulled inflatable boats, again, working with Cunningham Covers, we came up with a system whereby we would just have an inflatable section of tarp. I suppose this is something the industry would be familiar with now,
Mm-hmm.
but I suppose it's a really good example of, again, these iterative concepts. You know, the first one, the one that works perfectly well, but it doesn't mean there isn't something slightly better out there just with a small tweak. So now most of the workboats are going to have compressors on them anyway. So it's simply a case of deploying your tarp, inflating this inflatable section, and there you go. You basically have, you know, a kid's paddling pool inside a salmon pen that you now fill with fresh water. So the handling difficulties that we would have had are all entirely gone. So it's, I suppose sometimes it's the small wins that can mean most on a farm site. It doesn't have to be, oh wow, we've got a desalination plant. That's important for the guy who's pocketing the money at the end of the day, you know, the directors, the owners. But for a guy who's just working on the farm, he just wants to get his job done. He wants to do it as quickly as he can. And hopefully the likes of the tow bag and these inflatable treatment tarps, they're kind of a piece of that puzzle. They're, you know, a piece of the puzzle that helps the guys on site. In terms of where we go now, the desalination plants, we're already on the way there. So we've commenced our investigations into the use of freshwater lenses inside salmon pens.
Mm-hmm.
So we've carried out some preliminary work on that here, initially just to establish, can we create a lens of fresh water inside a salmon pen? So we designed a small, we call it a snorkel system. Again, with an inflatable ring on the top, because we don't need to have things solid anymore. We just have a small inflatable ring on the top. And then we use our on-site desalination plant that was only doing a nominal amount per day, about 50 cubic meters of fresh water per day, to fill into this open bottom system. So the fresh water could just flow straight out the bottom. And throughout the course of our trials, we established that we could get a salinity of about 3 parts per thousand within that snorkel, which is really, it's an excellent result for the volume of water that we were putting in there. The salinity was stable at a kind of a 2.5 meter to 3 meter depth. Our snorkel was 4 meters. And we're hopeful. We've done some preliminary kind of veterinary workups, and we're hopeful that that will show us that, you know, gill health is improved, say sea lice numbers are down, because the fish can sort of, I don't want to say self-treat, but the fish have a choice now. If they're swimming around in saline water and they don't fancy it, they can move into the freshwater snorkel.
Mm-hmm.
So the lens seemed to be established there, regardless of whether there were swells, there was wind, it was fairly stable. So it's certainly something that we would look to investigate more. We were doing it on the Marine Institute site at Lehnapool. So we have a really good partnership with the Marine Institute there, working on site with them and running sort of a multitude of trials in parallel with the trials that they are running. So I suppose it would be really nice to be able to run a similar trial on a full commercial sized pen, just to see, can we achieve the same goal? But I suppose the next step for us is observing the fish health benefits associated with that, if any. And then it's a case of, you know, kind of ramping up to see whether or not commercial cage trials, full-size commercial cage trials, are worth the investment.
Excellent. Okay. So if somebody wants to find out more or get in touch with you, how do they do that, please?
Yeah, we're always reachable. Yeah, you can just go on the BIM website and all the contact details are there, not just for myself, but if someone has an interest in seaweed or perch or oysters or mussels, the contact details are all there. I'm not sure whether we can kind of add a link onto this presentation at the end that kind of shows all those contact details, but certainly they could they could just ring the switch at BIM at Ireland 0121444100, and they'll be able to transfer you through to the right person. If you don't know who you need to talk to, if you just say it's aquaculture and the species, or it's just aquaculture, we'll make sure you get the right person to help you with whatever need you have.
Excellent. Thank you very much indeed for your time, Geoff.
Okay, thanks, Georgia.
Thank you.